evening. This event is co-sponsored by the program on the global environment as well as the University of Chicago Center for International Studies, as well as the Seminary Co-op. So I will turn it over to Seth Darling and Douglas Sisterson, and they'll be in conversation for you. Okay.
Thanks. Evening, everybody. So I'm Seth.
I'm Doug.
So we're both scientists at Argonne National Laboratory, just down the road, down I-55 from here. And just a quick introduction to our backgrounds, so you know why we ended up writing this thing. I'm primarily a researcher in solar energy, so not a climate researcher per se, but energy and climate are inextricably linked, and we're in the mess we're in because of our use of energy and the way we've used energy. And the ways that we can get ourselves out of this mess are also based on energy. So this is something that's near and dear to my heart day and day. Doug was my perfect co-author for this book because I'm not a climate scientist, but he is. So go ahead, Doug.
So I've been at Argonne for almost 40 years. I started out just in weather research meteorology, but for the last 24, I've been involved with the world's largest national user facility for climate research. And I've worked all through the program, even a facility manager, and that's been a really wonderful experience for me because everything we'll talk about tonight is not my personal research, but the research of 5,000 scientists that have used our facility over the last 2 decades. And they're supposed to give us highlights of what they find, and my job is to make sure that they have the measurements they need. So this is sort of their story. I've been able and very fortunate, so it's not about my research, but sort of the integral research of a lot of researchers. And we hope to share that story with you tonight as well as the results in our book.
Yeah, so what sort of led us to this is we both do a lot of public outreach, just kind of part of what we do day to day. We go around and give talks. And what happens to me, and I think Doug as well sometimes, is you give a talk and part of motivating energy, which is what I usually talk about, is climate and climate change. And just because of what's become a political debate, at least in this country, sometimes you get somebody in the crowd who voices some of these climate change skeptic myths. And some years ago, I was not that well educated on the subject myself, and there are a lot of unusual myths out there. The common ones, a lot of scientists, I think, understand the science behind them, but some of them are kind of out of left field, and I've got questions that I just wouldn't know the answer to. And what scared me is that it wasn't so much that person, because often when someone's really in that school of climate change skepticism, they're not, presenting them with the scientific facts doesn't necessarily change their mind. But there were probably 5 or 6 other people in the room who were left less sure than they were when they came in about the fact that we're the ones who are changing the climate and the climate is changing. And that really scared me, and so I took it on myself to really learn about all of these myths and why, what the science is that demonstrates that they're not correct, and realized that needed to get that word out there more, and that led to writing a book.
Yeah, I think what's interesting, like Seth said, is okay, I've been involved with climate research or weather research for a long time, and you might even consider me to be an expert, but I still get the question from the audience, and I don't know everything about everything, and so we could get tripped up by a lot of questions. So I too thought this is a wonderful opportunity to just kind of understand a little bit more about the book. So if you have a question about us tonight, we might go be looking through the book, but
pull it out
we can pull it ourselves. But and the other thing that was frustrating for me is that we all have interests and problems, and our focus for the issues in our lives are about this far if we have families. And so there's something as important as climate change. Where do you get that information? You can read about it in the Wall Street Journal or the New York Times, Chicago Tribune. You can listen to the news, but what I've noticed from the news is that, in fairness, they give about 50% of what I would call the consensus viewpoint, and they give 50% of what I would call sells the media, right? It's this far out, really, really outrageous kind of point of view, but the problem is they don't tell you which they're telling you at the time. They give equal time to it, and so if you're trying to get information, it can be very confusing. So another reason, my particular reason, was this is an opportunity to tell our side of the story and tell it in a book that doesn't have equations, and it's conversational.
But not just our side. So the media presents this as a debate, right? There's this climate change debate, but there's actually not a debate. So it's presented that way in the mass media, and as Doug was saying, newspapers, Sunday news programs all seem to give roughly equal time to what is the scientific consensus view and the skeptic view. The fact is, there's just not a debate in the scientific community, at least not among climate scientists, which are the folks who actually know what they're talking about on this subject. They've been extensive polling on this, and the number hovers sort of 97, 98% of climate scientists who are actually doing climate science research are on board with the fact that the climate is changing and that we are the primary cause, which are the two big factors here. It's just, there is no debate about that. That is a given in the scientific community today. So there's this big disconnect between the science and the way the science is presented to the public in news and in newspapers and so on. So we're really trying to push back against that as much as we can.
But part of it is the Earth is a round rubber ball. When you start science, you want to start with the simplest, eliminate all the variables, and kind of build onto what you know. So why we have I would almost say unanimous consensus about that the Earth is getting warmer due to the input of carbon dioxide from the burning of anthropogenic sources. The real issue is that makes a difference to us is when is it going to happen and what's going to happen where I live. And so the biggest problem we have is that on a global scale, the Earth is a round rubber ball. We have a pretty good idea of why we can start out as called it global warming. But we've learned and matured over the last 3 decades or more of understanding that it's just not temperature. It's much more than that. It's this heat energy that is being trapped, and where does it go? And ultimately, we know a little bit about weather, but we know very little about how Mother Nature works mathematically, physically in a model. And so what's going to happen when we put these things in here into what we know, and the Earth is a round rubber ball, what's going to happen to downtown Chicago, and when's it going to happen? What's the magnitude going to be? And so that's the part that we're still working on, trying to understand and get consensus on how all the variables in weather and climate interact to give us a pretty good indication by a forecast through a model of what will happen. And that's where I don't say it's uncertainty. We just haven't found consensus on the final what's going to happen here in the next 50 years.
Skeptics often prey on that uncertainty. There are things that are uncertain, for example, exactly which effect will happen and exactly where and exactly when. But that doesn't throw any uncertainty on the big picture of what is happening and what the cause is. Which kind of, let's maybe go through a few of just this big picture, some of these common skeptic myths. Do you want to do climate and weather since you're the weather guy?
Sure, the weather guy. So basically, there's this whole thing between climate and weather. So you think, well, if you hear about global warming or climate change, and you think, oh, it's going to get warmer. And then we had our winter last winter, and gee, only a few inches short of the record. I almost wanted it to snow one more time, right? And you think, well, okay, I'm out here shoveling, it's colder than whatever, and you're thinking, where's this global warming, right? That would be a skeptic's argument. But the truth is, we have to think of the world, the climate, as a global issue. It's not just what's happening here, but it's the averages of what's happening everywhere at the same time. So just as it was as cold here as it's ever been in a long time last year where we live, you could go to the northern latitudes in Russia and Europe, and even Barrow, Alaska was, we were colder than them most of the time. So you have to look at not just 1 or 2 days or events, but over a long record of time. And so climate is a 30-year average of the weather conditions where we live. For example, if you just take an hour temperature here in Chicago, every hour for 30 years, average it all up, you can do all sorts of statistics that says what's the average temperature on a particular day, a particular month. We can define seasons. The weather is what happens that day. It's what you get. So a good way to put this in perspective is then when you're watching the news, you'll always say, well, here's the high and low today. They talk about the normal high. That's the 30-year or 60-year or 90-year, or it's about multiples of 30, for Chicago. So you can track how much warmer or colder we are to that average. But if you really want to know if we're statistically really warmer and colder, you have to look at the number of times we're not only higher and lower, but how much. We might have a string of 30 days where we're colder, but then we could have 5 days which were way above normal. And so there are people to keep those records and statistics for every little climatic region of the world, and that's what scientists use when we're talking about climate, global averages, versus weather where we live.
Right. The point is a cold winter in Chicago does not mean the world is not warming. It's called global warming. We're talking about the whole world, and you're talking about over long time scales, decades, not single years.
In fact, one of the rapidly getting consensus about our weather patterns is that we'll probably likely see not just temperature, but we are focusing pretty much on we're going to see extreme weather events. That's the way that climate change will be recognizable to many.
Yeah, well, this is actually one of the skeptic myths, is that there are actually folks out there, and it surprises me to hear, but who fully believe that the climate is changing and that we are changing it, but they say it's not a problem. They say it's a good thing. They're going to have longer growing seasons at higher latitudes because it'll be warmer, or when the Arctic sea ice melts, that's a good thing because it'll open up navigation lanes for shipping across the Arctic Ocean, which would be more efficient, and new oil and gas drilling would be available where it wasn't before, and things like that. Some of that is true. Some of these things will be some advantages, but overall, the negative consequences far outweigh those few positive ones. So extreme weather is one of these. It's pretty well documented at this point that hurricanes are going to be stronger, and when one of those things hits a populated area, think Sandy or Katrina, so on, you talk about loss of life, of course, and also hundreds of billions of dollars of damage. And when those things are stronger, that just means more loss of life and more damage. You have phenomena like ocean acidification, which isn't as much in the media, but we put all this carbon dioxide into the air by burning fossil fuels, and the stuff that stays up in the air is what's causing the planet to warm up. But a lot of the carbon dioxide we put up in the air gets absorbed into the oceans. And when you put carbon dioxide into water, you get carbonic acid. And the oceans are actually becoming more acidic over time. You can measure it for decades. It's been getting more acidic. And that has all kinds of ramifications. It kills coral reefs, which are some of the most biodiverse places on the planet. It makes shellfish have trouble forming their shells, so clams and mollusks and oysters, things like that. It causes sea urchins to die. It causes all kinds of problems, ocean acidification. That's just one other consequence. Sea level is rising. Of course, that's a problem if you have coastal property, but it's a problem for lots of other reasons too. It increases the storm surge damage when there's one of these big hurricanes. It causes saltwater infiltration into freshwater aquifers, and we have limited freshwater resources, so sea level rise is a big problem, and that's going to accelerate. You have species becoming extinct all over the planet at unprecedented rates, not just in coral reefs, but in other places. As I already mentioned, we're losing fresh water, not just because of saltwater infiltration, but glaciers are melting, and there are huge parts of the world where glaciers are the primary source of their water. And so as those disappear, that will become a big problem for them. Diseases are spreading to new regions than they were before because things like mosquitoes can populate regions where they weren't populated before. So dengue fever and West Nile virus and malaria, diseases like that spread into new regions. It's a global health cost. There are economists who estimate the economic cost for climate disruption, climate change, and the numbers are in sort of the hundreds of trillions of dollars. So when you talk about the relatively modest costs it would take to mitigate these changes, they're tiny compared to what the costs are going to be if we don't do something about it.
I think one of the interesting things is, you hear about these things. Well, okay, so what about me where I live? If I put on my little glasses where I can see where's climate change happening near me. I bought my house back in the suburbs out by Orland Park in 1986, and I was going to be this environmental person, and all of the trees that we planted and flowers and shrubs were native plants for Illinois. Here it is, do the math, 28 years later, and what's happened? All my green ash trees are marked with big X's because the town's coming through to cut them down. I have 21 different trees in my yard, and 5 of them are being cut down because the climate has changed. We're no longer in zone 6, we're more like in zone 5. And so those are real signs for me. Those are the things that I really can see in front of me. I think there's other things that y'all probably had experience with, is like rainfall events. I mean, boy, I can remember when it would be nice, you could just, we're going to have a thunderstorm tonight. Garden variety, you could sit there, kind of enjoy it on the back porch and so forth. Now, we get like a 5-inch storm, and there's, we have to worry about high winds and power outages and sitting in our basements for hours at a time. And when we look at the statistics of the frequency that these things should occur, it's like the 500-year storm. And yet we're having them every couple of weeks. And so you say, well, what does that mean? Well, that means that now my basement flooded, okay, so I have to go. Well, my insurance company won't cover a basement flooded from a rainstorm. You know, if my water heater broke or my pipes burst, they'll cover that, but they won't cover, you know, a natural event. And so here I am saying, wow, it's time to go buy a generator, you know. So it has an economic impact there. And then if I want to get the insurance to protect myself against these, well, we've got to charge you more because the rate of insurance policies, their payout is based on how they have to pay out. They have to pay out a lot more. So all of a sudden my insurance premiums are going up for
Not
my
just
home.
yours, but everybody.
Everybody,
That's kind
yeah.
of the point, right? We all pay into insurance, so we all pay this cost, even if we don't live on the coastline or
Yeah.
whatever.
And it just amazes me that it's all connected. Almost everything you can think of about economics and something and health and weather and climate where we live, if you think about it long enough, it's kind of all connected. So we've been talking an awful lot. Do you all have some questions you'd like to?
I've never been a homeowner, but is there a difference between insurance that you buy based on weather-related versus just regular home insurance?
Well, there's a couple of little facts about this that the insurance company won't tell you, but one of them is that if you just get your typical homeowner policy and you don't read all the fine print, if your house gets hit with a tornado, that's an act of God and they'll cover it. But there's this new thing called straight line winds due to downbursts. And if your house has been destroyed by straight line winds rather than a tornado, that is considered an act of God and not covered by the insurance company. So that's why all these appraisal teams to go out and see if the damage is caused by a tornado or high wind. And guess what? You cannot buy a policy to protect you against straight line winds.
So they don't currently have insurance policies for...
They don't pay out and they won't offer you one, right? Because it's becoming kind of widespread. That's just one example. Yeah. I hope there's no insurance salesman in there.
Do you know anything about the people and the authorities in China understanding the situation? Because every person that I've heard of that has been there claims they're polluting something fierce.
So I mean, China just recently surpassed the United States as the largest emitter of greenhouse gases on the planet, but we can't really be pointing too many fingers here in the United States because we, for a very long time, were the biggest emitters, and still per capita, we are definitely the biggest emitters. So, you know, we can't blame anyone else until we're fixing our problems here at home, but this is a good point about this phenomenon of anthropogenic climate change, of human-caused climate change, is that the atmosphere is very well mixed. It doesn't matter where the carbon dioxide gets emitted from, whether it's here or China or India or Africa or anywhere else, it goes everywhere very, very quickly. So the actions of any one country affect the whole world. And what's very unfair about this is that most of the emissions come from relatively wealthy countries like the United States and places like Europe and so on. And some of the places that get affected the most by things like spreading disease and loss of fresh water and whatever are some of the poorest, least developed places in the world. So it's really there's an ethical question here about, you know, who's responsible and who needs to do something about this. The people being affected the most, feeling it the worst, are the ones least responsible for actually causing the problem in the first place.
But then more readily that it's a problem, they're not as much into denial. I think their problem is they keep pace economically.
Yes.
In China specifically, you're talking
Yes.
about, yeah. So yeah, by the way, China is the fastest growing solar market in the world. So they just need a ton more energy because they're developing so much, and so they're building coal plants, but they're also building, you know, solar power plants and hydropower plants and everything else. They're just getting all the energy they possibly can. I mean, there are softer environmental regulations, generally speaking, there, which is why there's so much air pollution in a lot of the major cities along the coast in China. But that's right. Yeah, we've been there. We've been there. That's right. Which brings up another point: that shifting energy from the fossil sources to things like solar and wind and other renewable sources doesn't just have the benefit of mitigating climate disruption. It also stops putting all this other junk in the air, which causes asthma attacks and cancer and birth defects and everything else.
But I think having been in central China, it's interesting. I mean, you have a different perspective when you find out that half the population in China doesn't even have access to running water and electricity. So they're almost where we were back in the days in the industrial revolution for us, where we could make electricity cheap with dirty coal. And so you want it to, but you're going to tell them, well, you can't have dirty coal electricity. You have to wait until you can afford a nuclear power plant, which means that even if they build it, no one could afford it. So you still have half your population that doesn't have electricity. So in a way, even some of the politics in that was the Kyoto Protocol to try to see if they could balance sort of a carbon kind of shares. Well, you get some and you can trade back and forth. I mean, it was a really good attempt to try and do that and to balance it. So it's economically known. It's just how do you implement that? And that's well beyond our pay grade. That's sort of more the social science, political science, economic policy.
Speaking of responsibility, the United States did not sign the Kyoto Protocol.
I have a colleague, another astronomer, who's a climate change denier, who cites strange things, cosmic rays interfering with the atmosphere that changes the. He also gives talks on the Maunder minimum, and I've seen him change the graphs in order to make his point.
Yeah.
He's still a climate denier. What do you do about that?
Yeah, so actually both of those
buy
subjects
this
are covered.
book. There's a chapter just on that
Let me tell you, so cosmic rays is a perfect example of one of those things that gets thrown at you if you're not well read in this field and you don't know how to respond to that because it's such a crazy idea. Basically, the cosmic ray argument is, so cosmic rays, by the way, are very high energy particles that are screaming through the universe like at crazy, they're actually shooting through all of us right now, cosmic rays. They're such high energy. And the argument goes, so the sun has a magnetic field, and that magnetic field affects the pathway of cosmic rays. And the argument goes that the sun's magnetic field changes over time, which will deflect more or fewer cosmic rays from going through the Earth. It goes on to say that so cosmic rays will go through the atmosphere and nucleate water particles, basically the initial parts of cloud formation will be affected by these cosmic rays shooting through the atmosphere, and so that if you change the number of cosmic rays, it changes the number of low-level clouds that form in the atmosphere. And low-level clouds affect climate. Net, they have a cooling effect. And the argument goes, the skeptic argument goes, that the sun's magnetic field has been changing such that fewer cosmic rays have been hitting the atmosphere, so that fewer low-level clouds have been forming, so that we have less cooling, so that that's why things are warming up. Follow all that? So it's a lot of steps.
It's more simply done in the book, yeah.
Turns out that basically none of that is true. The sun's magnetic field has not been changed. So you can count cosmic rays hitting the Earth, and they've not been changing in any way that lines up with the changes. I mean, that right there shuts it all down. You can actually look at cosmic ray counts over time and global temperature, and they don't go like this. Cosmic ray counts are kind of bouncing all around, and temperature's doing this. And so right there, it shoots it down. But even the other connections, like the fact that cosmic rays are actually affecting the number of clouds, even that connection doesn't seem to hold water.
Yes, so this is a good-natured question, but it's intended to rattle the cage a little bit. That's an excellent, the previous question is an excellent example of someone whose imperviousness to the actual evidence in question is really the basis for their misunderstanding of what's going on. If that imperviousness is present in that handful of people who asks those questions in every presentation, while the book is an interesting thing to have in my back pocket at a cocktail party when I'm conversing with somebody about this, what does it do in a larger sense for debunking if information is in fact not what these people are
that's
sensitive to?
This is a perfectly legitimate question. This is not a psychology book, by the way. So the titles, the title could be, you could argue it's mistitled. It's not really how to change minds. It's giving you the tools so that you'll know what the facts are and that you can make sure that maybe some other minds don't get changed. That's really the people we're after. As I said at the beginning, the person who's really an adamant climate change skeptic is not motivated, based on scientific facts. Typically, it's other stuff which giving them the science is not going to change. But what you want is the four other people who are sitting at that dinner party with you who aren't already climate change skeptics. You don't want them to hear this guy's scientific arguments and think that he's right. You want to know the facts so that you can explain scientifically why it's wrong, so that those folks don't become climate change skeptics as well.
I just thought about this when I was driving down, that our family has discussions and we have scientific arguments all the time. And one of those is that it's funny when you're in an argument, you tend to get louder and louder and louder. And so what I would tell my kids, what they would tell me is Dad, lower your voice. Don't raise your voice with argument. Give a more defensible, go look for better evidence, for your argument. And I think that's the case here. There's some that believe what they're going to believe, and there's just nothing you can do about that. But for those that really want to understand the scientific-based evidence, we provide that. And it's not a technical book. There's no equations. My daughter was the illustrator, and she does children's books. So we purposely wanted to make it so that you're sitting at Thanksgiving, you got some glass of wine or something, and you're sharing with the family, and Uncle Brad comes up, because Brad's their character in the book, and the skeptic, our foil, and he's just sort of brings this up. And so we want in that dinner time conversation, how do you fight back with Uncle Brad about, wait a minute, you missed some facts about that. So
and there's a full spectrum of sort of skeptics. There's the ones that just are, there's nothing you can do. But I actually have colleagues who work in my very division at Argonne, very well-educated people, I won't mention their names, who I discovered, much to my chagrin, were actually climate change skeptics themselves. And since going through this exercise, I've had conversations with them and presented them with the science on why they were not right. And they have changed their minds and now accept what is the climate science consensus view.
yes.
Yeah. Could you elaborate a little more about international accords or lack of accords and the United States' role in supporting or not supporting this? Because in a sense, maybe I'm jumping to a conclusion, the world as a whole, even though making these efforts, seem to have some stage of denial because they're always putting off goals to like decades down the road to achieve something.
That's right. Yeah, I think part of this gets back on, again, I'm not a psychologist, but there's this thing in human psychology that we're very poor at assessing long-term risk. It's why people smoke and do other things, right? It's that you're not going to get lung cancer tomorrow. You're going to get it in 40 years if you start smoking, probably. So then you smoke, even though you may know that. And climate disruption is kind of the same thing. We're not all going to be underwater because sea level's risen so high next year, right? A lot of these changes will happen at some point down the line that's kind of hard to predict. And because of that, the fact that it's a long-term risk, we don't take the actions now to mitigate them. We smoke. So the only way to fix this issue, to really fix this issue, barring insane geoengineering approaches, is to dramatically reduce our greenhouse gas emissions. And as I said, it's mixed all around the world. And so we all have to do it. It's not going to work if just China stops or just we stop or wherever. Everybody's got to reduce their emissions. And the only way to do that is with international accords, like what the Kyoto Protocol was the first real attempt to do. And so, hopefully this will happen going forward. If only Europe signs on or whatever, it's not going to make that much of a difference.
As researchers, sort of, I'll say this, that we sort of have this oath to try and find the truth. We try to be unbiased, and we take us like all your TV shows where it's some kind of NCIS or something, looking at all your different kind of, you go where the evidence takes you, right? And so it's really important that as a researcher that we're trying to understand how these processes work. Where we've been dragged into politics a little bit is when we get very impassioned about what we believe, but we want to stay on the side that we present the evidence to the policymakers, to the people that should know better how to take a scientific problem, translate it into an economic impact, and then try to, not only locally but globally, try to figure out how do they put all of their arms around it, because it's an economic problem. So we don't necessarily jump into the economics, although we'd love to, but I think we still stay on the evidence side of that. And so we're more focused on just trying to find what we would call the truth to base those assessments on. So,
yeah.
Well, yeah, there was actually.
It was just kind of a follow-up. I think you were talking about the psychological effects that people have and their impact on their way of viewing climate change. And you were saying it's almost like a sense of denial if you're not dealing with it now and pushing off until later. And so we do in fact do that with a lot of issues. I was wondering if there are any other bits of advice that you could offer to how to convince someone to focus on the now. And I think you started talking about that, like talking about local issues that actually affect people here versus talking about the rainforest or sea level rise in Europe when I'm here with my family. Is there anything else that you could add or?
There's a general statement I like to use just when dealing with people who are climate change deniers in general, which is, it's become a political issue, but it doesn't really matter what political party you vote for, if you don't vote, it doesn't matter what church you go to or if you don't go at all. Something that we all want is our children's lives to be better than our own, or darn well at least as good as our own. And that future is something that we are putting at risk by continuing to emit ever-increasing amounts of carbon dioxide and other greenhouse gases. And so we really have to shift this debate from being a political debate to being about the future for our children. And I think you'd be hard-pressed to find someone who would disagree with the fact that they want their children's life to be better. Yeah.
Right, yeah. Yes?
Sorry. Do you try to quantify the methane that's being released in the Arctic or was water related, and is water level increase uniform over the run of time?
Okay, so sea level rise, I mean gravity, yeah, so that if it rises, it's like not only the Pacific Ocean goes up, water, I mean gravity causes that to happen everywhere, right? Methane is a very important question. So carbon dioxide is the big one that you hear the most about as a greenhouse gas, but there are lots of other greenhouse gases, and one of the important ones is methane. That's natural gas. It's the stuff you burn on your stove or whatever. And that gets up into the atmosphere from various different places. One of those is that you just mentioned is there's a whole bunch of methane that's trapped. It's frozen up in the Arctic in various places. Some is just in the tundra itself. It's frozen in there, and other parts under the Arctic Ocean in what are called methane clathrates, which is like an ice that has methane mixed up in it. And as stuff starts to melt and thaw up there, that methane's going to go up into the atmosphere. And methane is at least 20 times stronger than carbon dioxide as a greenhouse gas. So we're warming the planet. That causes thawing and melting up there, causes methane to go up. That causes more warming, which causes more thawing and melting, which causes more to be released. And you get this positive feedback runaway effect where suddenly you can have pretty dramatic changes in temperature in pretty short periods of time, this is one of the real scary so-called tipping points in climate disruption, is the methane releases from these methane clathrates and from the tundra. Incidentally, there's another place where methane comes from, which is from us and from our own processing of natural gas. So there's a big boom now in the United States in hydraulic fracturing, right, which has allowed us to access shale gas and other resources underground that we couldn't economically get at before, which is economically has been great for the United States. We're going to be energy independent, I guess, by about 2030 is the projection. We won't need all this Mideast oil and everything because we'll have our own gas and oil here for quite some time, which in that sense is great. The problem is, and by the way, in methane, natural gas, when you burn it in a power plant, releases less carbon dioxide than when you burn coal. So in that sense, it's better, and it's viewed as a bridge fuel, is what folks will call it. The problem is that this processing, the extraction of the methane and transporting it to the power plants and all that, there's leaks, inevitably. And methane gets up into the atmosphere more than it did before. And this is very poorly understood right now, but it looks like there's a lot of methane coming up from this hydraulic fracturing, which is going to cause more global warming than if you'd actually just burned coal instead of the methane in the first place. So it's not such a great bridge fuel. It's a bridge to nowhere, really.
You mentioned quantification, so I'd like to comment on that one. Part of the research facility that I have, we have sites all over the world. We actually have 2 in Alaska. And there are actually experiments going on now for some of our users where we're actually, it sounds weird, but they're actually finding land where they're going to try to heat it up like the sun would heat it up and measure, quantify. We can theorize or hypothesize how much methane might be released, but actually have terrestrial ecologists and people that know about Arctic tundra, and actually warm it and chemically, collect that air and see what the concentrations are, and artificially warm it at a much greater rate than climate, so we can measure that. Same thing, we have a site down in Oklahoma. Matter of fact, I managed that one for a long time, and fracking is really big in Oklahoma, and we actually have a site within a couple of miles where they're actually doing fracking while we make all that background hydrocarbon emissions. So we've been watching how the background concentration goes up as they increase the drilling activities. And so, I mean, it's not there to police that, but it's a scientific opportunity that in a clean environment, watch how it's growing up around you and make some projections based on what you see. There are scientists that are doing that. So yes, there are not only talk about the effects of methane, but also studies to look at the quantification. And go back to those models and be able to put in some hard definitive numbers about the actual rates of release? That's a great question. Yes.
I know you already mentioned your expertise is in research, not necessarily policy prescription. Nonetheless, you're still experts. Could you comment on the success of the sulfur dioxide cap and trade in the 90s, and then why carbon cap and trade is not as popular, why it's not happening, or would it even be a good suggestion?
So on sulfur dioxide, here's your expert.
Yeah, I was back in the acid rain and the National Acid Precipitation Assessment Program, and I was one of the lead co-authors for exactly on trends and what happened, and it's an interesting story. I think the first thing is it's a lot easier to deal with the emissions from coal than it is from the burning of carbon dioxide, because most of it was really related to power plants releasing the fuel. And the scare was in the acid rain days that the acid in the rain that was causing all sorts of devastation to potentially crops. And our economy in the United States is based on trade of wheat. And boy, if our wheat crop was destroyed, that would really be a problem to our economy. So there was a lot of scare about that, but when they went in and did the studies, they said, boy, if we reduce these emissions of sulfur and nitrogen species from when they knew were coming from coal, we should, and there was enough study to say we should see, if we could get a 30% reduction here, we could see a 30% reduction in the precipitation. And that would be great. That would just make everything happy. And so they did this. They enacted policy, emissions went down. And not only to go down, but it corresponded to what we saw, the emissions reduction in the precipitation. But the one thing that just shocked the bejeebies out of everybody was that the acidity of the rain did not change at all. We forgot about solution chemistry, high school chemistry, that whatever we did to reduce emissions of the acid-forming species from sulfur, whatever power plant reductions, whatever electrophoretic trapping of the large sulfur-emitting species, also removed proportionally the base cations that would neutralize the rain. And so we saw the reduction of the sulfates and nitrates in rain. We saw it in the atmosphere, but we didn't see a change in the acidity. And ironically, it's the acidity that was causing the problem with the plants. Matter of fact, since this project is closed, it's interesting because it turns out that if you put a little bit more sulfate and nitrate nutrients into the rain, the plants are able to tolerate a lower acidity. So the problem almost got exacerbated. But in fact, it's not as near as bad as they thought with the acidity. So that all kind of panned out. But the reason why that worked is because it was really just the very specific species, sulfur and nitrogen, which is much far easier to mitigate than carbon dioxide.
And I know this isn't what you asked, but there's actually a really interesting climate connection between that phenomenon, the pollution prevention laws like the Clean Air Act that prevented these sulfur dioxide and other things from going in the atmosphere, and climate change, which is, if you look at the temperature record, global temperature record over the 20th century, it kind of warmed in the first part of the century, and then it kind of flattened out from sort of the 40s to the 70s, and then it started rising again until today, basically. And so there are, skeptics who argue that, well, we were releasing tons of carbon dioxide during, the 40s to the 70s. Why wasn't it warming? And the reason is those sulfur dioxide emissions coming from those power plants, which were going up with the carbon dioxide, they form aerosols in the atmosphere. And those aerosols have a cooling effect. And so we were warming it with the carbon dioxide, but cooling it with the aerosols, and those more or less canceled each other out at the time. And then we passed all the Clean Air Act and other legislation that limited those sulfur dioxide and other emissions, which was great because they cause problems, not just acid rain stuff, but other stuff. And all of a sudden it started warming again because we weren't doing cooling anymore. The warming was there all along. It was just being masked by the cooling.
So everything's connected, right? It's just what's weighing more at the time. Yeah, it's fascinating. Question?
At the outset, you mentioned an arbitrary media person who was inclined to give equal weight to the people who don't believe in the acid rain story. I wonder if in marketing your book you've run into those people and whether you've had any effect on that.
On media people specifically?
Well, yeah, I mean, you suggested at the beginning that maybe it was the media people that were the cause of all the
yeah, I don't want to put the, I don't want to put sorry if that was what we conveyed. We didn't mean to convey that the media are at fault here. But it is, so there is this feeling in the media that they want to present a balanced view, right? It's the obligation of a journalist to present all sides of an issue. And that has somehow morphed into giving roughly equal weight to the science that is anthropogenic climate change and the non-science, skeptic view. So it's been
just as wacky on the other side of it.
Oh, trust me, there's plenty of whack jobs all around. I get all kinds of correspondence. So I don't want to put all the blame on the media. It is a fact that there is this disproportionate emphasis on the skeptic thing.
Well, yeah, a little bit, but I don't want to knock the media, because a very good example is that climate change, climate disruption, global climate change, whatever you want to call it, is a tough story to sell or to tell in a short amount of time. For example, if we had a meteor coming and it was going to strike the Earth in 60 days, and we'd all be crushed and whatever, that would be pretty straightforward. You could, there's not too much that could, as you could look through your telescope and see the object getting bigger every day. But climate change isn't that thing. It's a little bit, it's here, it's among us, it's present, but it's sort of there and it's growing, but it isn't causing death and treading water within the next 60 days.
In the next 60 years, yeah.
Yes, you're right. But to tell the story properly is difficult. You can't just do it like a meteor's coming in 30 seconds, news at 10. How long will it take? Climate is a little bit more of a complicated feedback. It's how all these things are connected, and to accurately tell the story, it's not just about the atmosphere, it's about the ice, it's about oceans, it's about biodiversity, it's about disease, it's about all that. And that's really hard to do in a 30-second or a 5-minute soundbite. So in fairness to the media, it takes time we've been talking about it here for a while. How long does it take for the audience to get a feel for the complexity of the problem and where we really are with it?
There's also some very loud skeptic voices out there, and you can understand what motivates some of that, because unlike in the case of a meteor where there's nobody who's in the business of launching meteors at the Earth. So I said at the outset that the economic costs of climate disruption are going to be gigantic. Economists estimate hundreds of trillions of dollars, and the cost of mitigation are substantially lower than that. So as a planet, it just makes obvious economic sense to fix this problem. But there are people who will lose money in this transition from a fossil fuel-based economy to a different type of energy economy. If you're a coal miner, you're probably going to lose your job. And that's a problem. These are people who need employment, and maybe there's not other good employment options in West Virginia. I grew up in Western Pennsylvania. There's a lot of coal mining around there. You can enact smart policy that can do, for example, job training to retrain the type people like coal miners who are going to lose their jobs. But those companies are certainly working hard. It's their responsibility almost to try and keep their business going, right? And so they're going to invest money in voices saying that this is not a problem or that it's not happening, and that's part of why you hear so much of this in the media. It's a lot of loud voices.
I'm thinking you should send free copies of your book to everyone in the media.
We'd love to, but the publisher charges us.
I have a question though, and that is, fracking came out of the blue for me. It probably didn't for you guys. You probably, you were thinking about this stuff. I wasn't. I thought that, we made the transition from the petroleum economy as I knew it to hopefully solar, wind, whatever. But then fracking started, it was huge in this country. I don't care so much as where did that come from, as what is the new fracking, as it were? What are the new surprises that are going to hit us folks, similar to the way that?
Well, fracking was a different way to get at the oil or gas without drilling straight down, right? And so in Oklahoma, where our site is that poor part of the country selling mineral rights to gas companies to come in and explore was. The farmers are actually selling their mineral rights to keep their farms afloat, okay, for fracking. And so it's there. There's gas there. There's oil there in a new a new way to explore and extract the oil fairly efficiently. So there's more, I mean.
Now, I'm trying to think of a bit more generally
Okay.
than that. 30 years down the line, is there going to be some damn thing that I've never heard of that's going to make a big change in the picture?
I hope so, because
You hope so.
yeah,
You guys have been thinking
because
about
Yes.
so there are
Okay.
folks who project sort of what the energy mix is going to be
Yeah.
at various times out in the future. There's the Energy Information Administration, and there's an equivalent one, the IEA in Europe, that really look at this and sort of say, how is our energy portfolio going to change, decades out into the future? And if you had looked, before fracking became a big thing, they didn't see it coming, and so their projections were wrong.
Yeah.
No. And there are surely disruptive developments in energy technologies that will happen between now and 2050 that I don't see coming, and Doug doesn't see coming, no one sees coming. And indeed, we're probably going to need some of those, because the projections for what our energy mix is going to be in the year, say, 2050 is still almost all fossil fuels. A huge growth in solar and wind and hydropower and even nuclear and other stuff, because we need so much more energy. They're all going to grow, but it's actually going to be more fossil fuel use than we're using today, which is frightening. No, I mean, we have the resources. Thanks to fracking, there's enough natural gas in the United States to last for probably centuries. And coal actually would probably last for maybe as long as 1,000 years. So we're not going to run out of those anytime soon. We need to just stop burning them, because these other technologies are not disrupting the climate.
This is sort of the heart of the message, in that we all have to take, first of all, this is a side thing. Authors don't get to decide what the title is and what the book cover looks like. But the second thing is that's really, really important is, and a lot of questions we get, what can we do about it? In the cover here, we sort of looks like we blame industry, but we all use electricity. We all want to keep the lights on at night. And so I think we spend a lot more time in this book talking about what's our responsibility. What can I do about it? How can I, what does that mean? And so I had one question from a graduate student at a lecture once. He said, geez, I'm a graduate student. I can only afford this, afford this 20-year-old car as a gas guzzler. That's the only way I can get to work. It's all I can afford. And so the point is, well, I'm not going to worry about it, because look at my neighbor. They're using, a riding lawnmower to cut, 3 square feet of grass or something over here. And so I think that one of the things is to go back, well, what can I do about it? Even if you have an SUV and you can't sell it because you got 10 kids. Okay, I understand that. But maybe you want to plan your trips a little bit more efficiently. So one less trip a day. You've reduced your carbon footprint. Changing out light bulbs in the house. Using less electricity. It's what you can do, what you can afford to do with what you can do. Bicycle, actually, yeah. But my point is, if we sit and wait for others to do something, it'll never happen, right? So
yeah, you also can't stop there, though. I mean, absolutely do all those things. If you can do it, get the fuel-efficient car. Don't take the car at all. Walk, whatever. But even if we were all as efficient as we could possibly be, that would not solve this problem.
We have to get,
because the planet is using so much more energy everywhere. There's people who are using almost no energy who are now using energy. Even if we were, as efficient as the most efficient people ever to be, it would not be good enough. We need to have policies in place, which means there's something else you can do, which is vote. Put people in office who understand these issues and understand the science and are motivated to do something about it. Because without that, we're not going to solve this problem. We've got to stop the emissions.
Speaking of unintended consequences, there have been proposals for putting reflective materials in the upper atmosphere to reduce the effect and the wonderful benefits of volcanic explosion.
Sure. It's what they call geoengineering or bioengineering or some kind of engineering. Okay, so let me see if I can put this to you in a different perspective. I had an editor from a physics journal come up to me about 15 years ago and said that he had a well-known physicist that wrote an article that he had a way to abate hurricanes on the Earth. And so I'd like to hear this one. So basically in the back of the envelope, he saw that hurricanes are basically just rotating thunderstorms. Thunderstorms have electricity because they're giving all this lightning. So if you remember the first principles in physics, if you've got electrical current going around in a circle, you've got a magnetic field that's perpendicular to it. So let's put a big magnet in space and reverse the polarity of the hurricanes, and therefore we'd stop the hurricanes that all fall apart, problem solved. So he's asking me, do you think this is worthy of publication? Okay, now you're all sitting there thinking like, really? Would this really work? I mean, and if you want to give colleagues your credit, but when you look at the size of the magnets you'd have to put in space, it would probably block the sunlight anyways. And so there are these sort of back of the envelope things that look good, but then there's the practical realization of the implementation of them that make it really difficult. So when we go to using the entire globe as a laboratory for scientists to do experiments, I'm telling you, I'm a scientist, I'm a little nervous.
Yeah. Unintended consequences is exactly the point. There's the great story of the cane toads in Australia that I'd like to use for this. I don't know if you know the story. There was the sugar farmers in Australia, the early part of the 20th century, had some beetle, I think, that was destroying their crops. And so they thought it was a great idea to import these toads that were native to Hawaii or something that would eat them, would be a predator. Turned out that they didn't eat the beetles at all. They figured out another way to kill the beetles, but now those cane toads to this day are a scourge on Australia. They're going everywhere and they have toxic glands and they, like, dogs bite them and die, and it's just, they never thought about the unintended consequences. It was a disaster, didn't even solve the problem in the first place. Same thing here with the geoengineering. There's all kinds of crazy ideas out there, intentionally emitting aerosols into the air because they have a cooling effect on a massive scale and all of this. And it might have that effect, but it's probably going to have a dozen other completely unpredictable consequences, some of which may be way worse than the problem you're solving in the first place. It's so much easier just to not emit the carbon dioxide in the first place.
But we're thinking about that. And I like to tell this one, this is an interesting one about wind energy. And so if you've been out to California, you see they put all these huge windmills along the very edge of the mountains coming out the Pacific Ocean. And of course, it's very windy. You put these 100-meter blade things and for 80-mile stretch, and you use the wind to push the blades to generate the electricity. One of the unintended consequences is, okay, now the wind behind the windmills is less. We've taken the wind energy and we've made electricity. Well, it just so happens that whether it's coincident or not, there's still a lot of scientific investigations going on, but the wind that would push up over the mountains would create the rain clouds that would rain, guess where? In the Napa Valley where they grow the grapes. And over the last couple of years, they found that statistically there's significantly less rainfall. Gee, where? Right where they put the damn windmills. Oh, I did swear once. Okay. So the bottom line is that unintended consequence. Who knew? But I think we're smarter about that now. And I think that there are even whole organizations at Argonne that look for federally supported research programs. They have to do environmental impact statements. And we sound like this is a big boondoggle sometimes, but in fact, that's where a lot of the great questions are raised, and the experiments can be generated to look at those unintended consequences.
The most efficient way to move people on a daily basis is by train. And like, I don't understand, I know General Motors lobbied to have a lot fewer train tracks in the States so people can buy their cars. But why aren't we doing something like what Europe does? Have real efficient.
Well, you're not getting any argument out of me, at least for transportation, but then again, it's electricity that produces.
Yeah, but it still produces a lot more.
Yeah, mass transit is a more efficient way to move people, there's no question, and moving more people into urban centers is more efficient as well. There are lots of things. All of these can be ways to improve efficiency, and we should do all of them. As I said, though, even if we do all of that, that doesn't solve the problem. We still need to shift our energy from fossil fuels to other sources, or this problem's going to run away.
The problem is the amount of carbon dioxide doesn't come out of the atmosphere. That's the problem. It stays in there, and scientists are still trying to figure out how long, but at least 200 years, at least. And so until we find an alternative way to interrupt this cycle, and it's also, there's some scientific evidence that suggests that in the carbon cycle, that if you saturate it with too much carbon, it never comes out of the atmosphere. That's kind of scary. So even if we stop now, all the consequence, right? But
maybe we can delay the inevitable.
well,
Absolutely, I'll say it again, I'm fully supportive of more efficiency.
Whatever we can do, yeah.
Absolutely.
Less is better.
Yeah, so we're at an academic institution for scientists to a certain extent. So then what can academic institutions do in order to kind of start playing a role? Last year there was a professor from Cornell that came to speak about fracking and talked about the taboo of scientists speaking out against things like the media where they make it seem like there's still a debate. So what are the roles of academic institutions, professors, students even, in order to kind of change the dialogue around this?
So first of all, I mean, almost whatever your area of specialty is. So as as a technology or science person, we can try and develop the next generation solar energy technologies to make it cheaper and get out there more. But if you're in policy, there's obvious connections there. If you're in law, there's putting proper environmental laws into place. It's sort of whatever your area of study is. If this isn't a topic you're passionate about, you can actually direct your entire career towards doing something about this.
I think one of the things that we see too is that to solve the problems, the big problems of the world, it can't just be a physicist or a chemist or a meteorologist or a whatever. It actually takes a team of experts to solve the more complex problems. And so in the old days, old days, I mean, you go get your PhD, you would be the leading expert in this particular field in physics. So you would know more about the phelia on a leaf of an individual tree in the forest than anybody else in the world. But the problem that we're having is managing the forest. And so we need a lot of people interacting and disciplines interacting. And some of the things that we've heard even now that are very encouraging, that use your electives. Find about something else other than your very specific major if you want to be a physicist. But maybe you want to take something else that's environmentally related if you want to know more about how I can apply this specific knowledge to a more general problem and become knowledgeable about the problem. So universities could give more sort of gen eds, find some elected type things so that you're not so locked in that you don't find about the real issues in the world that what you're learning might apply to. Or even use universities finding more by example, lead by example, different ways to encourage more bike paths for around town, or solar energy or something like that.
Specifically for scientists too, I think this is a problem not just for climate change but some other issues too, where scientists historically have been a little too cloistered in our laboratories and not out there talking to the public about issues that affect them, and climate change is an obvious one. I think climate scientists, but also all the peripheral areas, soil ecologists that deal with it, ocean scientists, energy scientists like myself, all need to just get better at getting out and talking to the general public. I think it's a real responsibility of ours to combat this false debate
But Seth, that scientists mumble and talk to their feet all the time. We have no personalities whatsoever.
Yeah.
So we can write books.
I haven't read your book, at least as of yet. Do you say anything about the projected population growth and the relation of that to future presumed energy usage of various kinds and what all of the implications of that are?
Yeah, so we don't explicitly address population growth, but we do talk about the growth in energy demand going forward. And so today we use energy worldwide at a rate of 18 terawatts. 18 trillion watts is what we use worldwide today. So you can imagine light bulbs like 25 watts. So 18 trillion is the rate we use energy worldwide. By the year 2050, that's going to be 30 terawatts. So almost twice as much energy use in the year 2050 as we're using today, which is why the projections are that we'll be using even more fossil fuels than we are today, because these projections aren't accounting for the disruptive changes in technology that are likely to occur. So that's driven in part by population growth and in part by the fact that a lot of the population is developing, right? There are people with light bulbs and refrigerators and air conditioners and cars who didn't have them before.
There was a question. There was somebody back here.
You mentioned that you're not economists, but two of the myths that I think you talked on, that touched on, were one, the myth that it's not going to hurt us if there are net benefits, shipping food and so forth, and the cost from that period. But also that installing green energy will wreck the economy, stop using fossil fuels to wreck the economy. I should have, but even though you might not address those directly in the book, do you have go-to people for the economic aspects and for the conversion?
Yeah, so we do address that a little bit in the book, indeed. And the fact is there are actually some test cases out there. In the Northeast Corridor, there's a sort of a cap and trade system that's been put in place. And there were projections ahead of time that was going to make energy costs go through the roof there. And it hasn't. It just hasn't happened. The fact, every place where anything like this has been implemented, there's been virtually no economic loss. And in fact, in some cases, there's been economic growth attributed to it.
Does energy growth have to be inevitable if at such and such time man realizes that they can't do this, Mother Nature won't permit it? We have to go back to how they lived in the earlier times.
Well, I'm not sure we're going to convince anybody to go back to living like the Stone Age or whatever, but
well, they use campfires, which is burning wood, which is carbon dioxide, so that's not a good thing.
So again, this growth in energy is not becoming because you and I are using more energy each year. In fact, on average, I think per capita Americans are using less energy per year than they were the year before because we have more efficient appliances and cars that get higher MPGs and so on. So per capita, we actually are getting better. It's a little bit because of population growth, but most of that growth in energy demand is, again, coming from China and India and Brazil and Africa, the places that are really developing, where these are people who are living with very modest lifestyles, and you can't fault someone for wanting light at night so they can read their school books, right?
Or a really good book. There was a question way in the back.
I was wondering about the carbon monoxide. Is there any efforts to present synthetic photosynthesis cells to market them to the public and utilize them? Because the trees are disappearing and...
Right, so carbon dioxide is the primary greenhouse gas. And we talked about geoengineering earlier. One form of geoengineering that might actually not only make sense but be something we have no choice but to do is carbon capture and sequestration. And there are various ways you can do that. So right at the power plant is probably the place where it makes the most sense to try and keep the carbon dioxide from getting into the atmosphere in the first place. And there are places out there where they're trying that. Right here in Illinois, there's a project called FutureGen down in southern Illinois where they're going to try and pump the carbon dioxide from a coal plant back down into a cavern underground. And there are other ideas too to use the carbon dioxide. You sort of said as artificial photosynthesis is one idea. You can actually, so plants use it as food, right? And so in principle, you can use it as a feedstock to make chemical fuels and things like that, although it takes a lot of energy to do so. And there's lots of researchers looking at efficient catalysts and so on to try and make that work. So that will probably have to be part of the puzzle. But those technologies to actually make that work are quite a ways off, and we don't have the luxury of waiting for that to solve this problem. We've just got to reduce emissions. It has to happen.
Question?
On September 9th, NASA released a review of a coronal mass ejection that occurred in September of 2012. And their conclusion was that had the Earth been in its orbit at the point where that coronal mass ejection crossed, the entire world would be back in the 1600s because the entire electrical network would be. So the solution is at hand.
Well, at our own hand.
So you guys are talking a lot about small changes and accumulation and leading by example. How do you guys feel about kind of speaking about an institutional level, divesting from fossil fuels as an effective tool in instigating larger change?
Great idea, yeah. So that's sort of voting with your pocketbook in a sense on a very large pocketbook with something like the University of Chicago. There are actually a lot of economic advisors out there who are suggesting that people should divest from fossil fuels, not for any moral or ethical reasons, but for financial reasons, because as climate change proceeds, these may be very bad investments.
Yes.
Yeah, one of the things I've noticed with the climate change denial arguments is no matter how compelling they are not, they never seem to go away. Can you think of any that the deniers have realized that, hey, these are bad arguments and stop using it, as well as if there are a few of them, is there anything in common in the way that they have debunked they could be used on the ones that stick around?
Well, okay, so the biggest example I can give you that we can all relate to that's not with climate is there are researchers that go to the cigarette industry to show that cigarette smoking doesn't cause cancer, lung cancer, okay? How are you going to combat that? I mean, I'm turning the question around. We can't. I mean, we can't. But what we can do is take it to the grassroots, take it to the people. I mean, you all affect change by a vote. Your vote affects a person for a policy that affects a nation, that affects eventually a globe. And so being smarter about what you know about will be helpful in reducing the number of issues you have to debunk, I hope.
There are some common themes, though, that pervade many different climate skeptic myths. And one of the most common ones is cherry picking data. Yeah. This one shows up all over the place. We talk about this in the book, too. So there are climate skeptics who say that glaciers are growing, not shrinking. And it's true that if you look around the world, there's probably 5% of the glaciers are growing. So if you only pick out those and show that data, then it looks that way. Or that the planet's not warming because they can show for 2 years that there was cooling. So it's cherry picking little pieces of data, and it looks very scientific because it's data. But when you zoom out and look at the big picture, it just doesn't hold any water. So cherry picking data is a very common theme. I'm sure new myths will crop up that we didn't even put into this book because they're very creative folks out there.
But if you do, I'm sorry.
I was going to say it, but probably it will be the same sort of faults, confusing timescales, cherry picking, the same types of errors that are made in the existing myths.
And this is something that's sort of near and dear to my heart too, is that in the scientific community, anybody who's been a researcher, you collect data. And you just can't randomly throw out data because it doesn't agree with your hypothesis. We anguish over every single, you can't just, oh, I don't like this one, throw it out. I mean, there's been whole scientific publications where the slope of a line is changed by one data point. And so skeptics just randomly pick data. And I feel it's almost like an assault and an insult to the scientific community to accuse us of doing something that's not like a conspiracy. That I would assume that policymakers entrust researchers to give them the right answer the best we can. And to do that, we go through this sort of method that we remain loyal to our cause by trying to be objective and not just randomly accept. And that's why we have peer review and all that type of stuff. So it's really important that like I said, if you're a skeptic, you can just cherry pick data and throw stuff out there. And that to me is just, they'll never be researchers.
You're treating climate skeptics as though they're all kind of equal. Sorry that I'm oversimplifying, but it seems to me the few that I've met in my life that they don't see themselves quite that way. They do not have the funding that you guys have at Argonne National Laboratory. They have to find funding. And sometimes they find funding at tobacco companies or the energy equivalent tobacco companies. And somehow your employer changes your point of view.
Or perceived to change your point of view.
Yeah, that too. But I think, if we in physics and science lose our jobs, we're going to go hunting everywhere. In journalism, a lot of journalists who were formerly employed in newspapers and whatnot are out there being journalists as second jobs now because they don't have the funding that they used to have in the normal chain of employment. And I think something similar may be happening on the fringes of it is an unfortunate word, but on the periphery of science. They aren't all bad guys. They just
don't mean to imply they're all bad guys. And by the way, just to avoid any misconception, times are not lush anywhere in science.
Yeah.
It's actually been quite rough. There's been, federal funding for research has been not going up for a while now. But in terms of getting funding for your work, the way scientists get their work funded is you write a proposal and it gets reviewed by experts, and the way the system is supposed to work, and there's not a better system than anyone has developed, is that the best ideas get funded. If a person who is predisposed to be a climate skeptic is proposing a project that is based on bad science, it's probably not going to get funded because it's bad science. It shouldn't get funded. If they have an idea that might actually be plausible and should be tested, hopefully the system would fund that work. And in fact, all of these questions have been explored from all kinds of different angles. Every imaginable explanation has been tried to be thrown at this, other than that we're causing it with our emissions, because that'd be great if that wasn't true. I would love that if we were not causing this warming with our carbon emissions. The fact is there is no other explanation that anyone has put forward ever that can provide, that can explain the phenomena that we're observing.
I'm trying to say there are reasons people out there are doing this, and we need to look at that aspect of it also.
Absolutely, but let me another insight into science. Let me give you another viewpoint. That we all have ideas. My boss had this sort of speech for me when I got hired at Argonne. Science is about failure. So I come up with an idea, And the idea is that I think this is an explanation for something. And I put myself out there, and you know what all science is about? Proving that idea wrong. So science is skeptical by its own inherent in self way it works. Why do theories exist? They exist because nobody can prove them wrong. It's not because you can prove them right. So in a way, science is skeptical. But it's a different kind of skeptical. It's we're agreeing to science-based evidence is going to be the judge based on objective data. Here's mine, prove me wrong. If it can be proved wrong, so be it. I'll modify it, try to do it better. But a skeptic doesn't, the skeptic that we're sort of talking about here tonight can be the skeptic that doesn't want to follow science-based evidence. They just want to shoot potholes of it. So I would say that there's different kinds of skeptics. Because scientists are skeptics.
Yeah, I told you I have colleagues at work who were climate skeptics and change, and they're good friends of mine. So these aren't all bad people.
Yeah, okay.
Yeah. Well, let's take one in the back here. So, yes.
Oh, thank you. I have a question that is tangentially related to this previous one, and I'm wondering what happens, like taking the example of being funded, like submitting proposals for research. Hypothetical situation, but I'm not sure this is so hypothetical. I mean, what if the funding agency, like often, from what I've seen about climate change skepticism, is that it's often correlated with the political right, often the far right. And I'm wondering if depending on who the funding body is, and whether or not the political agenda lines up with the project. Like, do you see that as a legitimate concern, or does that come up in your work at all?
So the decisions, again, for most federal funding agencies are not made, what's going to get funded and not funded is not made by the agency. There's no political appointee involved in that decision-making process. There are peer reviews. The National Science Foundation, I go to Washington, D.C. and sit on a panel to review proposals from professors at various universities. I don't work for the National Science Foundation. I can't even get money from the National Science Foundation being at a DOE lab. So it's just they bring in experts. It's scientific experts are the ones who decide which proposals make sense and which ones don't. And the political decisions are about how much money will the Department of Energy get, but not about which specific projects will get funded.
And there are themes within federal agencies. If you carve up a pie in research, some will do medical research, some will do this kind of research, and so forth. So you have to go to a sponsor that's kind of in that realm that has congressional responsibility for that type of work. But yeah, we don't see that political issue of it.
I mean, one thing to add to that is, I mean, scientists are people too, right? And everyone has, we all have our own biases, right? There's no such thing as a truly objective person. So of course, biases find their way into these processes, but there's no intentional or unintentional conspiracy to, push out a certain line of thought.
I mean, I guess I say this because it's not so idealistic in the social sciences. Like if I apply, as a Canadian, if I apply for funding from the Canadian government to do research, and it's undermining, it could reveal things about things that the Canadian government supports. I'm not so sure that would so easily get funded. And I'm wondering, maybe it's very different in science.
I don't know.
I think if a climate scientist was skeptical of the consensus view and could make a legitimate argument that there's some plausible argument that they might have, that should be able to get funded.
Yeah.
The chairman of the House Science Committee is
we all saw the Comedy Central
special. Climate change denier. He's a creationist, and he believes that the changes that we see in the climate are determined by God.
Yes. Yeah.
And he's not going to fund anything.
Yeah. So that's an extreme case, and it is a little scary who some of our elected officials are and what positions they sit on. A slightly less extreme viewpoint of people on that same committee, the House Science, Space, and Technology Committee, which is obviously an important committee for this issue. There are some folks on there who have equally incorrect, explanations, but not quite so supernatural. So there's an argument that the climate is changing for natural reasons due to changes in the Earth's orbit, and it is true that if you go back in the ice core record, if you dig down in Antarctica into the ice, you can pull up ice cores that have chemical and other signatures of what the Earth was like over hundreds of thousands of years into the past, literally like 800,000 years into the past. And you can see these big variations in our climate, where it's gone from being very, very warm to being most of the planet covered by glaciers, ice age type situation. And that has happened completely irrespective of our power plants, right? This was hundreds of thousands of years ago. So it's true that there are natural variations, and those are driven mostly by changes in the Earth's orbit, the way the way it wobbles, the shape of the Earth's orbit, and so on, changes how much sunlight hits the surface, and that causes these variations, which, by the way, are also fueled by carbon dioxide. The planet warms up, releases carbon dioxide from the oceans, which causes more warming, which releases more carbon dioxide, and so on. So there are natural variations over various timescales. But the changes we're seeing now are happening far faster than at any point in that geologic record, and we can actually attribute them directly to our emissions. You can actually measure that the greenhouse effect is happening using satellite and Earth measurements. You can see that less long-wave radiation is getting out because it's being trapped, and then more is being reflected down, direct measure. And you can directly measure that carbon dioxide concentrations are increasing in the atmosphere, and you can directly measure that that increase in carbon dioxide is coming from fossil fuels because of isotopic ratios matching those that are in fossil fuels. So it's just, the evidence is all there that it's happening, it's not natural, and that it's us.
Yes.
I have a question. You brought up two instances during this talk of science kind of getting it wrong, and that was the instance of the acid rain, and also the windmills, the ocean. And that had kind of unintended and fairly serious consequences for farmers, especially in the drought-ridden state. And I'm wondering kind of how you address the concern that even with the consensus that not so much that climate change is wrong, I think that's fine, but like that our solutions might cause other types of problems, or that it's kind of, you know, we're stuck with it, maybe we should just kind of hunker down. I don't know.
Yeah. Yeah, sure. So one of the examples I use, like in the scientific method, that, you know, scientific consensus is based on the best evidence we have at the day to make a decision. And if we can get sort of one more than half of the experts to believe that in a poetic kind of sense, we have consensus. But a scientific consensus is 100% correct. I can think of a certain part in our lives that we thought the world was flat. Okay? So, but the point is that science is always challenging sort of the state of what we know. And as technology comes along and we get better gadgets and things, we can go get more data than we had before. That doesn't mean that once we've said this is truth, we abandon it. It's always going to be questioned. So we always try to challenge and move it forward. So we're more mindful of consensus, and we do like to listen to the negative viewpoints, because the negative viewpoints aren't all skeptic. They're just, I don't see enough data to support your argument.
Two things I wanted to add to that. So first of all, hunker down is not an option.
Yes.
So adaptation is going to have to be part of the story, because we've already changed the climate, and it's going to keep changing. Even if we shut off all our emissions now, it's going to change more than it has, because it takes a while for these phenomena to happen. So we will have to have adaptation. We'll have to probably build some seawalls around places like Miami and
That's mitigation.
Places like that.
I get them confused. Anyways.
But if we don't make any attempt to mitigate emissions, if we continue on the business as usual scenario, the changes are, it'll basically destroy the society as we know it at some point. It's just hunkering down is really not an option. Now, in terms of unintended consequences of our alternatives, which was the other part of your question. So let me take solar as an example. I'm a solar energy researcher, so it's one that I know more about. There are negative environmental consequences of any energy technology. Doug mentioned this one that comes up sometimes with wind. With solar, there are ones too. So a great place seemingly to put solar panels would be out in the California desert. Lots of sunshine, and you're not in the way of anybody out there, right? So it seems like a great place to put it. But there are things out there like the desert tortoise. The desert tortoise is an endangered species, and if you build a solar farm in the habitat of the desert tortoise, you're going to kill desert tortoises. They might go extinct. That would be a bad thing. What places like Argonne do, though, is environmental impact statements. So the federal government owns a huge amount of land in the American Southwest. There'd be great places to lease out to companies to build solar farms. but you don't want to, for example, kill desert tortoises or cause other problems. And so we go in and we analyze over dozens of different potential areas of impact. So wildlife is just one. There's also water resource issues, paleontological issues, Native American rights, aesthetic issues, all kinds of things. Basically everything you can imagine in terms of consequences. And they are able to evaluate, this is not my area, but there are folks who are expert in this, evaluate what the impact would be if you were to build a solar farm in a given location. And they can identify in this spot you will have the smallest environmental impact. And so here's where you can get sort of pre-approved to build one. So this is not something that gets ignored. We think about these consequences intelligently. Surely there might be some things that we don't foresee, but the big issues I think have a pretty good handle on, and there's just no question, even if you kill the desert tortoises, that's better than building a coal-fired power plant.
Question. So does the DOE actually make any energy policy? It seems like they fund a lot of research and whatnot, but when it comes to actual energy policy, most of that's actually Congress, right? Should they do that?
Okay. So DOE's mission is to provide a safe and secure national energy policy. Did I get that right? I think that's the one line that it does. But you're right. It has a responsibility for gathering the information for a national energy policy. But you're right, laws are not enacted by the head of the DOE. So there's various agencies that have these realms of responsibility that things to affect the nation as a whole. And obviously it's up to Congress and the Senate to pass the rules and the
way it's
regulations.
supposed to work is Congress brings in the scientific experts to inform them
That's
to
the way it's
put
supposed to
together
work,
good legislation that's based on sound thinking.
Scientific merit,
So with campaign finance the way it is, and given that energy is a large industry, do you see anything really changing in our energy policy other than these disruptive developments like fracking, which is not necessarily positive? I mean, that will keep people getting elected, right? No matter how many of us vote.
Are you asking, are we optimistic that this problem is going to be solved? I waver on that. So there are a lot of signs that point to make you not be very optimistic. But there's a scientist, you actually know him, Ryan, Dan Nocera. He's a researcher who does solar fuels, and he came to Argonne and gave a talk about this stuff. And he does his research because he's driven by climate change arguments. And he said it's a very he's very pessimistic about the outlook, but as a scientist, it's our obligation to go down swinging, was the line that he used. And I kind of like that. It struck a chord with me that, even if we are screwed, it's our responsibility for our children to do what we can about this. Now, personally, I don't think we're actually screwed. I think, in principle, even with today's technology, there are solutions to mitigate a lot of this problem. It's really more of a political, social barrier that's in place, not a technological one. And that's why we put energy into things like writing this book and coming and talking to you guys and whatever else, because the more people who do this, the more likely it is that we can do something about it, as unlikely as it seems that we'll be able to.
Yeah, the scary part is it'd be really nice if, like a meteor was only 30 days away. I mean, we'd all jump up and try to do something about that. But I think that what we're also trying to do is show the signs of what climate change, what form will the enemy take, right? And so that's we're gaining consensus on that. But I think if people start to understand it's a complicated process, but you can look in your neighborhood and see what's changing in front of you in your lifetime and know that that's rapidly accelerating and it's going to be a bigger issue. And of course, the whole drive to tie it to economics, it really hurts when it hurts you in the pocketbook. And so to try to take all these things that we see and put an economic value to it, that will also start to drive Congress into taking more rational approaches towards mitigation or adaptation or research. Way in the back.
I have another question. There's a current study by Swiss Bank that 48% of the wealth in the world is owned by 1% of the population. So is there any, since there's a huge economic impact of what is yet to come, is there any talks with that 1% population to...
We'd love to go to Bill Gates and tell him that we'll put his face on every climate research facility we put around the world if he would give us some money.
She makes a great point, which is that these are the folks who stand to lose the most economically. They've got the most money, and there is going to be a huge economic cost associated with this. As I said, there are economic advisors out there who give multiple reasons for divesting from fossil fuels today. I'm not one of those 1%, so I can't speak for them. But you're right, that's actually not a bad strategy, is to try and get those folks on board.
1% are also the least vulnerable to climate change.
That's right. They'll be able to they
hunker
can hunker
down
down.
longer.
They
Yeah.
can hunker down.
I guess going off of that question, I feel like a lot of investors who are maybe not quite part of that 1% are starting to move, yet so much of the media is depicting this scientist versus business. How do you think, would you have any proposals of how to show that there actually is consensus growing between these two seemingly political and media motivated polar opposites, and it's actually one line?
Yeah, I think what makes that complicated is that business is not a monolithic thing, right? I mean, science kind of is on this issue, right? As we said, 97, 98% of the climate scientists are on board with this consensus, but in business, there are lots of different types of businesses out there, and those who stand to gain and those that stand to lose, and there are probably a lot more who stand to gain, but the ones who stand to lose are really loud and have some deep pockets. So,
I mean, you see that a lot of actors and actresses will take up a cause, and some of them are for the environment. I mean, it's nice to have a spokesperson that would cheer you on that's recognized by millions of people. But it's a tough one. But there's other things out there, like I joked a little bit, but Bill Gates actually, very little people know this, put into a patent for a special type of pump that was strong enough that if you put them on barges, they could actually pump a lot of the cold ocean water up to the surface, which the intent was to get out ahead of a hurricane. And since the warm ocean waters are the fuel for them, if you get up well enough of this cold air, it would mitigate and stop a hurricane. Once again, I mean, it's great intentions, and I'm glad to see things like that. But when you talk about how much water would have to be pumped in a short amount of time, it's a little unrealistic. But there are good stories out there. How come we don't hear those? I agree. You guys have been hanging with us for a really long time, and I appreciate that. We certainly want you, I'll be shameless and say, buy something. We'll be glad to sign it for you. Or give you time that if you all got someplace to be, you've been with us for a long time, we really, really appreciate it. This is our first real kind of author kind of thing, so we're kind of excited about it. Thank you. Yeah. We'll be glad to hang around until until the bookstore closes, but it's a great Thanksgiving Christmas present.